Hello, today we'll be checking out an earthquake in Northern California, and we'll be checking out a weird rumbling earthquake in Western France. Starting over in California, yesterday there was a magnitude 4.1 earthquake near Fortuna. This was at 1816 UTC. It had a maximum, did you feel it, of 4. It also had a shake alert generated for it. Also, interestingly, it had a 28.4 kilometer depth, which is different from the standard of 10. So it's not necessarily a deep earthquake, but it's deeper than usual. Also, there was 508 responses. Coming over to their shake map solution, it looks like McKinleyville felt an MMI of at least 2. Also, here are the plotted responses pretty much across that whole area there on the coast. So it looks like there are many seismic stations available in the area. So here are a few stations I was able to pull up. Looks like they're all on the BK network, which is the Berkeley network. Here is an NC, which is the Northern California network. Another BK. So it is that signal at the top here. It is that green line. It happened almost 24 hours ago, so most of it is cut off on these graphs here, which only show the last 24 hours of data. Also, on all these stations here, I can also see this other signature right here. It kind of looks like tremor, but this is a distant earthquake at that time. So just real quick, there was a magnitude 5.6 near Tonga at 0750, which is that signal we can see on the other graphs. So I always like to check out the shake alert data for earthquakes that generate one. First of all, on the map here, it does look like its location was just slightly off from its final event location. It initially picked it up as a magnitude 3.9. It only reached a maximum of an M4, but it created a tidal for an M4.3, so I guess I do not know what this tidal means exactly. Interestingly, it says Fortuna would have gotten 0 seconds of warning time, which does make sense. A slightly more distant city here, Fort Bragg, would have gotten about 28 seconds of warning time. These are the warning times if, say, in that same location a stronger earthquake were to occur. These are about the times you would expect these cities to get a warning. Also, this earthquake did create a tsunami information statement. It basically said there will be no tsunami. So let's come back to Tonga for that magnitude 5.6 earthquake, which occurred actually today at 0750. USGS has an MMI of 3 for it. It has 1 felt report on the USGS. Zooming in a little bit, this was just south of American Samoa. So this is kind of weird. There is a station here in American Samoa. This is IU AFI station. It has a weird signal here at around 2100, but it has nothing at the time of the earthquake. Actually, there does appear to be a little blip right here. I'm not sure if that is it though. Coming over to Western France in Brittany. There was a magnitude 3.9 yesterday at 1952 UTC. Now this had quite a few felt reports. Of course, they are all in French, but they all report feeling a rumble or a sound. Here they said, heard a big boom without knowing the reason. Rumbling, weak shaking. Heard a rumble like a thunderstorm. Rumbling. Dull noise and boom. Loud rumble. Prolonged rumbling. As if a fighter plane was under the house. Explosion, followed by rumbling, vibration. Like a plane breaking the sound barrier. Loud noise. Very loud detonation and house shook. Explosion, then jolt. Anyway, you get the point. It was loud. Very loud. Why was it so loud? So let's come over to the Raspberry Pi shake map. This is basically somewhat amateur seismometers, but they are kind of a powerful network. So we can see that magnitude 3.9 right here, and then just west there is this icon right here. This is a station with an infrasound sensor. This can hear low frequency sound. So we can actually hit this download last 24 hours of data. Coming in here to 1952 UTC, we can see a clear signal. There is a clear disturbance from the background noise. Open the spectrogram without changing anything. There is a bit of pickup around 25-20 hertz. Now we can see that signal again. It's still hovering at around 30 to 20 hertz, and the sound lasted for. Looks like the sound lasted for a good 20 seconds in this section right here. It's about 20 seconds. Going back to the waveform, we can zoom into this extra spiky section, and we can see this is also about 20 seconds long. So this is the same signal that we did zoom into on our spectrogram here. Anyways, we can see there was clearly a sound generated from this earthquake. Of course, a lot of earthquakes do generate sound. The pressure wave is a sound wave. However, this earthquake was especially noisy. Considering it was only a magnitude of 3.9 and had quite a few fail reports, at least in my opinion, for the EMSC. And then just a little bit more data. This is the same station that we saw that infrasound. This is its seismometer, and this is what it picked up for that earthquake, including what seems like a very small foreshock. Alright, so finishing off on earthquakes over in Hawaii. We have seen a slight uptick in magnitude in the past 24 hours. Coming over to the seismometers in Hawaii, pulling up the HHZ channel. You can let a few more of them load in here. So we got a couple of stations to load here. Here are their locations on the map. Coming down here to their data, these are on the HV network. We can see a couple of signatures on this graph. A few more signatures on these graphs. Here are the same signatures. Coming down some more, we can keep finding these same signatures on all of these graphs. Coming over to the latest Kilauea update, there is nothing new of note. Likewise, coming over to the Mauna Loa update, there is nothing new of note. Coming over to Hurricane Roslyn, it actually made a devastating landfall as a Category 3 hurricane in southwestern Mexico. It is currently a tropical depression and it is sitting in southern Texas. Coming over to the New York Times, they report unfortunately there are at least 2 dead. These 2 deaths are unfortunate, however both of them do look like they are a result of building collapse. Coming back over to Windy, they are currently tracking tropical storm Sitrang, which is currently making landfall in Bangladesh. Coming over to the NHC in the Eastern Pacific, interestingly, they are no longer tracking Roslyn at all. They have nothing listed in the Central Pacific. And then coming over to the Atlantic, they are currently tracking disturbance number 1. It has a 70% chance of forming a cyclone in the next 48 hours. They are currently forecasting lots of rainfall for the Bermuda area for this disturbance number 1. Also, they do list a number 2, which is not on the map here. You can see this system here just north of Puerto Rico. They say formation chance for this system just north of Puerto Rico through the next 5 days is low or about 30%. Coming over to Windy north of Puerto Rico, we can see that system a little bit better. Thank you for checking out today's video and stay tuned for the next one.